Welcome to 2018. This is being recorded on January 1st in anticipation of a class which will be delivered on January 4th. As you can see, the title of the class is YDNA, an introduction. It's the first of 4 sessions that we will go through to try to prepare the modern genealogist to deal with the choices available from current YDNA technology. The first question, the most obvious thing to me, is why are we doing this? What can you get from YDNA testing? Is it worth the money? Well, in my experience, you can get the location of your ancestors in prehistoric times. You can get when they were at various times, prehistoric and even after surnames. And you can also figure out how they relate to each other. To explain these a little bit better, the first thing I'm going to show you is a few maps. These are genetic maps of DNA types. Haplogroups, as we call them, are designations with the letters A through the alphabet. I don't think we've got to Z yet. The predominant haplogroup we'll see in this chart are the R types, which are the Europeans, including Great Britain, and the I types, which are a lot of the Scandinavians, and all the surrounding ones. You'll see that we started in 2000 with the first map, and we move forward through time. This map is a distribution of Y DNA haplogroups in Europe, created in the year 2010 by Robert Gable. You'll notice he's specifically giving you not just a letter, but a number following that. For example, this I1 up here. The I is the type, the 1 is the subgrouping. And as you look at these other places, I1, N1C, those are not I's, those are N's. You can see over here in Iceland, there's R1B and I1. If you go down to Great Britain, you'll see there's the same mixes with different numbers after them, R1B, M529. If you get down into Southern Europe, Spain, France, you'll see R1B is prominent as opposed to the R1A that's in the eastern part of Europe. And if you go south, you'll see again the I's are south as well as north. Here's another map done in 2012, and you'll see they've added more hatching to show mixing, different peoples mixing with others, living close to one another. And as our anthropology work is moving forward, and they've started adopting the new tests that the genealogists have been using for a couple of years now, they're able to label their samples much more specifically, and we're able to get more and more specificity in the time of prehistory from anthropologists. Generally, we will see people trying to generalize and say, as you can see, the R1A here is the same place it was before, but it shows a lot more area. And R1B is taking part of the area that was previously called R1A. These charts move around, and different scientists looking at different samples get different values. This series of charts are generated by Genetic Genealogy in Ireland. They've been the leaders on this new science over the last 2 years, maybe more. You can go to YouTube and you'll see many videos, many lectures that they've put out. They have a new set that's just come out or is coming out from the most recent conference they had there. They start out with this basic chart showing a group of people with various Irish surnames that they think are related somehow. And they title it, "What Does This Offer? The Family and Surname Researcher." Back on the theme we were talking about just a moment ago. What are we getting out of this? They break the chart apart by time periods. They label time before the year 700 as prehistory. And you'll see the red dotted line going through this picture that you can't see any of the small print on. Then we move to the year 1200 where we have surnames. And you notice they don't let the lack of surnames or the prehistory stop them from drawing their family tree charts. Here's a brand new report that came from the company YFull, which is one of the several companies, one of the better companies in my opinion, that's analyzing our workforce now to help us understand further. And in this example, you can see they have Greeks highlighted in the year 1950. Before now. That's 1950 years ago, not the year 1950. And you'll see there were Greeks there. And if you study the structure of the chart over here on the left side, you'll see there's a vertical line that goes down the left side of the screen with branches off of it. And some of the branches indent further. For example, the Greeks are an indentation. Then it indents further to get closer in time period to a group of people they haven't identified. And then it gets to a Jewish type that's even closer in time than the basic indented group. So they're saying from this group of DNA, it appears this Ashkenazi Jews probably came from Greek ancestors. And as you go on down, you'll see they're trying to identify the types of the people down below. You might have noticed on that previous chart also we were showing times. In small print you could see it, but if we look at the reports we'll show you the big ones. And the time periods we're looking at are 3,000 years ago and closer. For example, this is a book that I put together. My goal of this book was to put my research down on paper where I could share it with others. And what I have done here is I've taken a group of men who genealogically are related, and we'll show you more about that later, and tried to use the latest, newest methods as shown by the Irish to figure out when and where and how are they related. The top part of this chart right below where it says next generation DNA testing for genealogy using family tree DNA's big Y test and YFull's analysis service, you'll see YFull's interpretation of how far back the common ancestor is between these four people. The horizontal lines with letters in front of them are a different person. And if you look at the far right, if you could see the small print, you would see the closer ones say 60 years and the longer ones say 740 years, and they average it out at 269 years. The bottom part of this chart is the tree, much like the tree we saw before with the Jewish and the Greek people, and it's showing that this particular group of people, my three relatives and myself, was formed about 3,000 years ago, 2,900 years ago, but our particular common ancestor was around 400 years ago. This is sort of the incompletion. What did the test accomplish, these two reports? Prior to that, we were looking at surnames. We still do, but not as rigorously. As you can see here, this is a Rader DNA study over the last 15 years. At this point, there were 59 people grouped together who have names like Rader. And if you look at the right column, you'll see there's values that start with I and R's and even some E's. And you'll see that there's different numbers of people in the group. The original group at the top, Adam Rader, is a dentist out of Los Angeles who wrote a book in 1980 about his Rader line, as they're called in America. The second group of 6 men is Caspar Rader's descendants, my line, and you can see that we have a different type. Adam Rader is the I type, and we're R type. And specifically at the end of that detail is an M223 for them and an M269 for us. That tells you specifically where your DNA is. And as you go on down, you'll see there are more people with totally different DNA that are never related in a historic time period, let alone surname time period. So this makes you realize that you maybe can't rely on the surname as much as we thought we did. And biology is showing your biological relationship, not your social relationship. So my point of that book and this slide is to try to emphasize with you that the companies and a lot of people are almost to a fad where they say you should take a DNA test. My experience tells me when you do a DNA test, you don't get near what you could get out of the tool. If you bring other people along with you that you think are related, you get much more. So you should use DNA like any other type of record to prove your research. And in the Y-DNA world, I always hear the female saying, I don't have a Y chromosome, so I can't do this. Well, let's look at my condition. I have 16 surnames at the great-great-grandparent level. How do I get these 16 couples, 8 couples, 1, 2, 3, 4, 5, 6, 7, 8 couples? How do I get the Y-DNA research on all of these people? I have the Y-DNA in myself for the person called Rader down on the left side with a red arrow pointing at him. The other 7 people, I do not have a Y-DNA in my body that came from them. So what I want to help you understand is the fact that I'm a male lets me get one of the 8 groups, but it doesn't get me the other 7. I have the same problem with the other 7 that the females have. They don't have that Y-DNA, and neither do I. Now, the thing that you need to get up on speed on and get comfortable with is you need to start widening your tree, your family tree. Don't look at just a straight line. Look at the neighbors. Look at the brothers and sisters, the aunts and uncles. This topic is generally called the FAN system. There's many lectures out there. You can get this one at Family Tree Webinars, as you can see in big print. It's a great lecture that shows you by how to do true genealogy today. You'll notice they have FAN, GPS, and DNA on the puzzle pieces. The 4 types of DNA research that we are using now is the one this talk is about, Y-line research, using the Y-DNA. The next one is the mitochondrial DNA, which we won't cover. The following one is the autosomal DNA, which is what Ancestry is doing in big time, and the X chromosome they're also doing. But this talk is specifically on the top topic, the Y-aligned research. Genetic genealogy. What is genetic genealogy? The relationship between genetic genealogy is measured by 2 ways. One is using what's called Y-stir markers. Another one is called Y-SNPs. And the relationship between those 2 has not been fully established. That's what the Irish are trying to do. When do you use one, when do you use the other, and how do they overlap? For you to do this whole process, the Y-DNA study, you need to bring some of your male relatives that you may have found through Ancestry. The Ancestry test brings you living cousins. If you use the Ancestry's test, which is a totally different company than this is, and you have many females out there that you find are related, the thing you need to do is contact those females and ask them about their male relatives. Do they have the surnames you're researching? So those males will have the DNA you want. And the way we gather them together and cut down the cost is first you go to familytreedna.com and you want to find out about that surname, the surname that male has, the surname that's one of your 8 groups. The first thing you do is down on the bottom on the front page, you'll see that this top slide, we have the most comprehensive Y chromosome, autosomal, mitochondrial ancestry DNA database for genetic genealogists. And to the right of that, it says search for your surname. Well, I put in there my surname on the bottom picture, same picture just filled in. And it brings me to a page like this. You notice down under projects, it says there's a Rader project that has 104 members in it. Well, your goal is to come this way into the service, the Family Tree DNA service, because you will get a discount and you will also be connected and put into a group study where other people who are studying that surname will help you understand what you're getting. And also you'll see that the test that's recommended right now by them is a $300 test. You see the Y11 DNA above the gold arrow at $300, $299. Well, I'm diverging from that goal. After doing all this, I find you can get that same information and not pay for it this way. First, you want to do the YDNA 12, which is the one with the gold arrow. It's only $59, and you want to get bunches of your relatives on a particular branch together to do that test. And if they do not match on that test, then they are not biologically related. If they do match on that test, it just means they're candidate to test further. It doesn't prove they are related, but not matching is just an automatic, no, they're not related. When you click on that order form, all you do is check on the gender box, type in the tester's name, which is the green arrow, the blue arrow for the male, and then proceed to checkout. And you'll see it's $59. It never goes on sale. It's the cheapest product they have, and it'll get you two things. It gets you that information of the beginning measurements of your Y-DNA, and it gets the sample put in the vault, so you can test that sample later without going back to that cousin. So you want to get permission from that cousin so you can manage his test as you move forward with further things you may want to know. This is the final page where you actually pay for and give the shipping information. You obviously need the shipping address of the person who's going to donate the sample, but you might want to leave your email address in there as an email address and a password for your control of the sample. Here's one less slide recommending family tree DNA. It's from another company that rates genealogy and other products, and you can see it has a very good rating. Another thing to know about them is they believe that your DNA is your DNA. They never sell, lend, or let anybody else look at your DNA unless you tell them to. So let's go on into how I did this test. What did I make of it? How did I get there? These people were discovered with regular genealogical methods, although you could also use ancestry tests to find cousins, to find their male relatives with the surname you would like to study. Now here's the group of people. Up at the top you'll see Casper, who was born in 1732 and we don't know where, and 3 of his 5 sons and their descendants. And down near the bottom you see James, that's me. Harry is one of my cousins that's branching off, as you can see in the middle. And Alton and Earl are both 4th cousins of mine, once or twice removed. Here's a map of where these people lived. You notice up here in Pennsylvania is where they were as kids. Then when the father wanted to retire, he moved down to YFull, Virginia. Can't make an arrow, can I? And he retired there, and his children moved on into East Tennessee for the land that was available there. Good farming land at good prices. Alton's line, who comes from Philip, went north to get away from slavery. He married a Quaker girl, and she didn't want to be around slavery. And Earl's family moved to Madison, Alabama, I believe that is, and later on ended up in Texas and came on into California. And the majority of the rest of the family stayed right there in Greene County, Tennessee. They're still there today. So you can see the 2 straddled families, Alton and Earl's family, are far away from the rest of the group, so there can't be any extra help in fathering children or anything. So whatever DNA they brought with them when they moved, that's what they got. So as you see again, here's the same chart. Blue and for pointing at Alton and the red arrow pointing at Earl. Those are the 2 guys that moved far away from the family. And the 2 of us in the middle stayed with the family group. So Casper Rader, or Roter as he spelled it, Reuter, is the brick wall. He had a bunch of children, and I managed with genealogy to find direct male descendants to test, 4 of us. And using the STIR technology, which we'll talk about first, and the results of their tests of 37 marker tests, you can see on the left here the genetic distance has a number. In the middle you can see a number which is the number of markers, I think. And then the genetic distance is how far apart they are, and you can see that Alton, Earl, James, and we don't have Harry in here. We have my brother Bob, and we have other people, but you can see my closest group have a 0 genetic distance. And if you look on the right side, that 0 genetic distance equates to 150 years, according to Mike McGee's tool. And so we can use this to help us figure out where we are. If you look closely, you'll see a gentleman named Gernot. He's a guy from Germany who's done his genealogy back to the 1500s. And I would like to be related to him. But you'll see on the left, he's 16 genetic distance away from me, which translates on the right to 5,070 years. So my Casper was not a close relation to Gernot. So we didn't hit a home run here, but this is one of the many tools you'll find we could introduce as we go through the next 3 weeks that we can show you to figure out how to understand all these numbers you get back. So when you do a STIR marker test, you notice the one we did up above was just 12 markers. And you see here I recommend 37, 67, and 111. Well, that was before we got the big Y test. Now with the big Y test, we get 250 or more all in one package for a much less price. So we want to get into the game, and they won't let you take the big Y until you've taken a Y test. So the 12 marker Y, which is only $59, will save you hundreds of dollars that you would have spent on getting these higher marker tests. But if you aren't going to do the big Y, then you should at least do the 37 marker. So what are the expected relationships with Y DNA STIR matches as opposed to SNP? We'll cover both those. The expected relationship between you and your Y DNA chromosome DNA Y match is dependent on both the number of markers you've tested and the genetic distance. The chart we'll look on the next page shows that interpretation. So you can see in this chart it has columns over here at the left. For example, here where I'm making the red squiggle, that's the 12 marker I'm recommending you take today. If you didn't have the big Y again, you would want to go higher to get more accuracy, because as you can see on the 12 marker test, you have to have, you can't have any errors to be related. And if you have one difference, you're probably related, and with 2 you're definitely not. Whereas you get over to the further test with more markers, you get a much higher degree of accuracy. And of course the thing you want is very tightly related, which is something happens very often, but I got there. Here's another chart that tries to show you the same thing. You notice on the left there's the number of markers in this column, and then going across is the genetic distance, and you'll see under the 12 marker test we're talking about, the related box is here where you got 0 difference. Where the rest of them, the related box moves on out and you get tightly and very tightly related. And of course this very tightly related gives you confidence that within a short period of time you have a common relative. And here's what you get on 111 markers in my case. I'm just showing you a small piece of them because that's the only place that there's any difference. You see Alton has a different value, 21, on DYS 712, and you'll see Earl has a different value on DYS 636. Other than that, all four of us have the same values every place. With the big Y test, you'll see that just the first one I'm showing here, I have not 111, but I have 280 markers, stirs, to compare with, and I have 3 different. So again, we're comparing these people, Alton, Earl, Harry, and James. So let's go on into the next generation testing. The big Y test, as it's called, has retailed at $5.75 for a while. It has sale times, Christmas time being one of them, where it comes down $100 or more. I think this last year it was down below 500, and there was coupons available to get you down another 100. So this test is going to explore your Y DNA, or the DNA of each person you run this on, looking for 25,000 known SNPs and looking at 10 million places on your Y DNA. It's going to find SNPs that are completely unique to you. Now notice these are SNPs. Now we're talking about SNPs, not stirs. It's going to explore your deep parental ancestry, and it's going to help contribute to advanced genetic anthropology. The goal to use an NGS test is to define the tree of your group, which will help you discover their history. You'll read virtually all of the Y chromosome that is useful for genealogy. It'll try to reach back in time for connections. It will connect outside the limits of Y DNA stir tests, where the Y DNA stir tests don't go as specifically as the SNP test does. And it'll supply points between 500 BC and 1500 AD, or closer. Other information from the big Y: does the family have any unique mutations that only your family has? What other groups share your unique mutations? When and where did the splits occur? And put the results together with stirs and SNPs, and you can do quite some tree like we showed earlier. So it's 110 to 170 years between SNPs. Now a SNP is an occurrence, an error that happens in the Y DNA. When the male creates his sperm, he sometimes will make a mistake, and that mistake is called a SNP. And that will happen around 110 to 170 years, so we're talking about maybe as much as 6 generations between errors. And let's look at just what the big Y gave for my study. With one person testing the big Y, just me, it shows on this chart that my most likely ancestor is back 2,884 years before present. With 3 big Y tests, it's 389 years before present. You see, it came way in closer. And with 4, it comes into 269 years. If we take that 269 years and compare it to Casper's birth, our brick wall, he was supposedly born in 1732, which would be 285 years ago, and estimated by this test is 269 years. Close enough for government work. Now, as we go into some other things that are things you'll want to understand as we move forward, the names for labeling these SNPs, the errors, are included on this screen. If you look up at the top where you have the part that has a purple box on an A2, that's what the name used to be before they decided needed a simpler name. So the name for my unique SNP was R1B1A2A1A2 A1B1 A1111121. And before that, it was the next line down. And then they decided, well, let's just take the R and add the name for the most recent SNP. And that's why you have the RY15783. And down below, the current one is YFGC35930. So those are just names for handles to have a unique name for each location. And you'll see when you look at the four of us with various tools, what is the terminal SNP? Well, if you look at family tree DNA's analysis, you'll see the left column. If you look at YFull's analysis, you'll see the right column. And you'll see they are not the same. This slide is a spreadsheet that I made up of the results as we got them back from the big Y. The column on the left, the SNP name, is a name that was given to these locations as I had a fourth company run another DNA test looking at those locations, which are in the numbers like in the green column. That's the physical location of the SNP. And I had them name them. And I did that because for two reasons. At that time, we were still in the infancy of the big Y, and they were questioning how reliable the big Y was. So I had them do a Sanger type test on my test particularly, and had them name each location. So from then on, we'd know who's who. Then if you look at Harry in the second column, which is blank, it's not no color background, you'll see there's places that there are no values. Harry's test did not return as high a quality, as strong of values at those locations. It showed that it detected them, but it did not call them as what they would call it. Earl in the next position, you'll see, has a couple of 1 mark, 2, 3 markers in the blue column that I don't have, and some of those Alton doesn't have. So you can see there's differences between each one of us. Now, what do you do with that information? What I did was I went to the Russian company, which was recommended by Family Tree DNA, called YFull, YFull.com. And they did the analysis from here on. So you can see here I've highlighted some of the boxes to make what I just told you clearer of the differences. And even closer, if you're having trouble seeing from the back row, here's a couple of closer shots. Here's the result that YFull came back with. And if you look down at the left column, you'll see FTDNA. And next to that, you'll see RY15783. That's what Family Tree DNA's ability to analyze this did. That's where they said our most recent marker is. YFull was able to take that down one more branch and call it RFGC35930. And you see the green arrow pointing at that. And where YFull, where FTDNA was showing it was formed 3,400 years ago, YFull says this one was formed 2,900 years ago. And the time to the most common ancestor would be 400 years ago. So you can see they've added value to what Family Tree DNA was giving us. This is that same information taking the time period. In the bottom part of this screen, you'll see the four of us who had these values. You'll see the difference in time in this right column, age by this line only. It shows Earl shows this SNP occurred 216 years ago. I show it occurred 60 years ago. Harry shows it 740 years ago. And Alton shows it 60 years ago. And if you average that, you get 269 years. And just to throw a little confusion in here, here's the results from 3 of the tests. And your question you're asking as you do these new tests is, how well did the test do? What did it find? What kind of accuracy? And you'll see on the left column, the first box with a blue top on it says it got 0.55 gigabyte of data. The next one down got 0.67, and the next one got 0.78. So you'll see as these tests are running, they're getting different qualities of data, different process passes through. How many times did they get through and test each location? 43, 60, 66. So we've got a lot to go, a lot to learn, and in the next 3 classes I hope to enlighten you more on what we're looking at.